In the technical details of an AC unit, you will typically find 2 kilowatt values. One for capacity and another for power input. In this video, we are going to learn specifically about the capacity kilowatt. In our previous video, we generally looked at the difference between cooling kilowatt and electrical kilowatt. I am leaving the link to that video in the description for those who need to watch it. An AC unit's capacity is usually stated in BTU or TR. For context, TR stands for ton of refrigeration and BTU stands for British thermal unit. For example, you might see it listed as a 1.5 TR AC or an 18,000 BTU capacity AC. Much like BTU and TR, the capacity kilowatt value is also used to indicate an AC unit's capacity. The kilowatt value of a 1 TR or 12,000 BTU AC unit is 3.52 kilowatt. The kilowatt value of a 1.5 TR or 18,000 BTU AC unit is 5.28 kilowatt. Therefore, a unit's capacity can be interchangeably mentioned as 1.5 TR, 18,000 BTU, or 5.28 kilowatt. But let's learn exactly how this 1 TR, or 12,000 BTU, became 3.52 kilowatt. In the beginning, people thought heat was an invisible liquid, much like water. They believed that heat was present inside every object, and that this heat flowed from a hot object to a cold object. When it flowed like that, they believed the heat would drain completely out of an object. Furthermore, they thought that when we heat an object, we are essentially pouring heat into that object. In 1798, when Benjamin Thompson was boring cannons for the military, he noticed continuous heat generation from the process. If heat truly was an invisible liquid inside an object, that fluid should eventually run out, but here, heat was being generated apparently without limit. So, they came to a conclusion: heat is not a fluid, it is the energy associated with the motion. In 1843, a man named James Joule conducted an experiment known as the paddle wheel experiment. In a fully controlled enclosed environment, he filled a closed vessel with water, noted its temperature, and continuously rotated a paddle wheel placed inside the water. The friction between the wheel and the water generated heat and increased the water's temperature. After rotating the wheel for a specific amount of time and checking the water's temperature, he noted that the temperature had indeed increased. Joule then came to a major conclusion: a specific amount of work will always generate a specific amount of heat. We explained this in our BTU video. The amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit is exactly 1 BTU. Now, in this scenario, instead of applying direct heat, we can use a paddle wheel to raise the temperature of 1 pound of water by 1 degree Fahrenheit. At that time, there was already a unit for work called the joule. For example, if you lift one apple to a height of 1 meter, it means you have done 1 joule of work. If you climb one step on a staircase, it means you have done roughly 150 to 200 joules of work. By rotating the paddle wheel, 1055 joules of work is used to increase the temperature of 1 pound of water by 1 degree Fahrenheit. So, just as 1 BTU of direct heat is used to increase 1 pound of water by 1 degree Fahrenheit, 1055 joules of mechanical work is used to achieve the same result. Therefore, 1 BTU is equal to 1055 joules. We know that 1 TR is equal to 12,000 BTU, so, if 1 BTU is 1055 joules, we can determine the value for 12,000 BTU. 12,000 multiplied by 1055 is equal to 12,660,000 joules. Therefore, 1 TR is equal to 12,660,000 joules. We calculate TR and BTU values in hours, so 1 TR is 12,660,000 joules per hour. In 1882, the British Association introduced the mechanical kilowatt unit. According to this, 1 joule per second is equal to 1 watt, and 1 kilojoule per second is 1 kilowatt. Since we have calculated the 1 TR value in joules per hour, we must divide it by 3600 when converting this to seconds. 12,660,000 divided by 3600 is equal to 3516.67 joules per second. If 1 joule per second is equal to 1 watt, then 3516.67 joules per second is 3516.67 watts. When converting this to kilowatt, we get a value of 3.51667 kilowatt. When rounding this value to the industry standard, we get 1 TR at 12,000 BTU is equal to 3.52 kilowatt. So, this is exactly how we got 1 TR as 3.52 kilowatt. Since we can represent cooling capacity in kilowatt, and the electrical unit is also measured in kilowatt, professionals will use both the cooling kilowatt value and the electrical kilowatt value to calculate an AC unit's energy efficiency ratio. So, this is the history behind cooling kilowatt. Altogether, we use these three units, BTU, TR, and kilowatt, to mention a unit's capacity. If this video was useful to you, please like the video and share it with anyone you think will find it useful. And don't forget to subscribe to our Zebra Learnings channel. Thank you.